And we know it is not a poisonous or yellow or green, right? So as it goes through this chemical change, what happens is the properties completely change because they chemically join or combine to create something new. So the second type of compound we're going to look at is molecular compounds. So what are molecular compounds? Well, they are also a pure substance, and they're formed when nonmetals join. So they're formed of nonmetals when they bond. So these molecules are formed through something called covalent bonds, which means there's a sharing of electrons between the bonds. So when we did the Bohr diagrams, this is where the covalent bonds come into play. So if I have an atom with space on their shell, their outer shell, there we go, because this one can fit it. This atom right here can make a covalent bond with another, can make another bond with another element. So I'm not putting in the element in the middle because I'm just making this up as I go. So here, these guys are going to share to make a covalent bond. So they're sharing this bond, and that's their covalent bond. So this is a molecular compound. So most share the same properties. They can be solids, liquids, or gases at room temperature. Okay, so molecular compounds share these properties. They usually are good conductors of electricity, or they can be poor conductors. And they usually have a relatively low boiling point. So probably the most familiar example of a molecular compound, is H2O or water. So it's made up of 2 hydrogen atoms and 1 oxygen. 2 hydrogen, 1 oxygen. And its properties are it's a colorless liquid, it boils at 100 degrees Celsius, stable in sunlight, dissolves the chemical potassium iodine, and does not bleach pigments, so it doesn't bleach things. So we're going to compare this with another molecular compound called H2O2, which is hydrogen peroxide. So you might know this from your medicine cabinet. You use it for cleaning out sores and scrapes and whatnot. So this is a molecular compound because it's made of 2 hydrogen atoms and it's made of 2 oxygen atoms. So its properties are it's a blue liquid, boils at 150.2 degrees Celsius, it breaks down in light, it reacts with the chemical potassium iodide, and it has a strong bleaching agent, which means it bleaches stuff that it comes in contact with. So the way that atoms are held together by different bonds makes their physical and chemical properties so different. So just because they're made up of these two, are both made up of hydrogen, and they're both made up of oxygen, some people might think, oh, well, they should be the same. Well, when you get to understand chemistry and how compounds are formed, again, when they form, the bonds and the different types of bonds that they form makes them have different properties, which makes chemicals so useful. All right, well, some elements exist in something called diatomic molecules. Come on. Molecules. So what happens is these molecules are called diatomic molecules because they have to have two atoms of the same element. Okay, so oxygen can't exist by itself. It has to be O2. That's how it exists. Hydrogen can't exist by itself. It's H2. Nitrogen's another one. N2. Fluorine is another one. F2. Chlorine's another one. Can't be by itself. Two of them. Bromine. Iodine. And astatine. I don't know how to say that one. AT2. Alright, so those are diatomic molecules. So, are they compounds? Not really, because they're not made up of more than one element. It's just the same element. So they are just called diatomic molecules. So, now knowing what you know, you can take your understanding of the periodic table of elements, the elements and compounds, to figure out, well, when I have something like this, what in the world is this made up of? So, the chemical formulas identify which elements and how many atoms or ions are in each compound. So, if we look at NaCl, I know that is made up of one sodium and one chlorine atom. How do I know that? Well, I look, and you want to look for, when you're looking at chemical compounds, you want to look for capital letters and a small letter. If you have a capital and a small letter together, that means that that is one atom or one element. If you have another C, and this one is another capital and small letter, there's another element. If you have something like this, KCl, the K is one element, the Cl is another element. Okay, so that's why it's so important to make sure you have, when you're writing them, you have the capital letter. When you're writing the symbols, you have the capital letter and the small letter, if there is one, and written correctly, not all capitals. Otherwise, it's totally different compound. So if we look at another example, H2O2, we know this is made of hydrogen. You can use your periodic table to figure out what the element is by looking for the symbol, and we know that this is oxygen. And the numbers behind, if there is a number behind, it tells you how many atoms of the number, the element in front. So this says there's 2 oxygen, and we know that there is 2 hydrogen. So that's just interpreting and figuring out what chemical compounds mean or what they are. So what you're going to do is you're going to complete a formative assessment on this to show me that you understand how to interpret chemical compounds. Use your notes, use your periodic table to help you out, and remember the number goes to the element in front of it, and look for big letters and little letters to tell whether it's one element or 2 elements.